Okay, for this I'm going to go through just a few of the ideas we have from class and then lead into a demonstration using cryptools. So I hope that at least this would help you get through the lab, right? So in class we talked about how do we apply cryptography, and we saw there was symmetric, asymmetric functions. There are also one-way functions, mathematical functions, how to deal with large data. Message authentication, maybe I'll do a different one for that, just so we can focus on the asymmetric and symmetric. In order to keep this video short, I will just stick to the main things in cryptools, right? So we said there's symmetric and asymmetric encryption. Symmetric means one key for encryption, the same key for decryption. Asymmetric means two different keys. It's important to realize what the importance of having one key means. One key means you would have to have both the sender and receiver have the same key, right? And asymmetric means you now have two keys, so one person can have one part of the key, the other person can have the other part, and there are many benefits to this. Usually there are some assumptions, and the assumptions are it should be difficult to crack the encryption. So seeing the encrypted information should not make it easy for you to see the unencrypted information, right? And if you are talking about asymmetric, even if you have just one of the keys, you shouldn't be able to easily figure out the other part unless you are the person who generated them. Usually the person who generated them creates the two keys together. So in that case, the creator can easily see it, but once he puts out the public key, that's the one he's giving out, the person getting the public key shouldn't be able to just figure out what the private key was. He would have to know, oh yes, he can decrypt something that was encrypted with a private key, but he can't figure out what the private key was. And anyone watching shouldn't be able to do so. Okay, so let's start with some preliminaries. So from last time, we saw in Excel just an implementation showing you how to encrypt. This was a symmetric one, so we had some information, a character, we changed it to a decimal. That was the hex representation, that's the binary representation. And we subtracted 65 just because it was alphabets. So A was 0, that's 65 minus 65, B 1, C, and so on. What we do is we add a shift value to it. This is the Caesar cipher, a shift value. So 0 plus 5, 1 plus 6. But what if we added something? So something like, let's take Z, which is 90. Subtracting, we get 25. But when we add 5, we go to 30. But remember, we only had 26 characters. That's what we are using. You can actually have more characters. If you have more characters, you just have to tweak the algorithm. So we now are up to 30. But since we have only 26, it means that when we go past 26, so 26 modulo, and this is where modular arithmetic becomes important. 26 becomes 0, 27 to 1, 28, 29, and 30, and so on. So it wraps around, and that is what is meant by the Caesar cipher, so that the numbers are shifted, right? And so what I said was, if you shift something, so if the shift is 0, you can see it's just A, B, C. If the shift is 1, it means that A has gone and wrapped around to become Z, or Z, right? And so on. So if I say 5, it just means that A, B, C, D, E has gone to the other side, that has wrapped around. You can see it here, A, B, C, D, E. And you can show you the code. So 90 is 69 and so on, right? So this shows you the code. Now, this means that if we type HELLO, the result should be MJQQT, right? So very easy to do. Now let's explore cryptools. Cryptools is free open source tool, right? I'm going to close most of the things here and start from the beginning so you can see how I got here. Right. If you begin cryptools, the first thing you see is the start menu. For most of the things we are doing, we are going to be focusing on templates. And that's, at least using templates, you can get along. get things started very quickly, understand how things work. So the templates are actually a very good way to learn and build skills on your own, maybe even do things I have not yet done, right? So if you click new, you get a new template and you can start pulling components onto the screen, right? You can see when I click anything, it shows me this gray box around it, and I can expand or make it smaller with this one, right? There are these inputs, and if you put your icon on them, you can see it changes. It says text input, external alphabet input, shift value. This one here is text output, right? And the ciphers are all here, classical ciphers, the modern ciphers, and the modern ones are grouped into symmetric and asymmetric. I'm clicking to expand and collapse these, right? Stenography, I think I have more, right? So I can shift this up. You can see if I just drag and drop the divider, so there are more things under stenography. Hash functions. So yesterday we looked at some of the hash functions. So for this lab, I'll just pick one symmetric, one asymmetric. We'll look at the hash functions and discuss how to use them, so you can finish up the lab. Crypto analysis. This is an analyzer, an attack. So there are all these things that you can actually, right? So this one says this is encrypted data. That's a frequency list, and that's an output. So for the different ways that you attack some form of encryption or encryption algorithm, there are all these that are already made for you, right? There are also some tools that are available. So Boolean operators, clocks, things you can place in dictionaries, inputs, outputs. So anything that is not really encryption, decryption related, you'd find it here. So right. But we can't go through all of this right now. To get you started, let's go through the templates, right? So you'd have to drag drop each of these to look at it. And what you have here is everyone has usually settings that shows you how do you configure the system. So you can configure it, and as you're configuring, you can see, for example, this Caesar cipher saying when it is 0, A goes to A. That's what we saw in the Excel. When it is 1, A goes to B, and so on, right? So next here we have the log that tells you if there are errors, warnings, or anything. You have here the data, that's whatever is inside it, telling you about the different things that are going in. So here you have text input, external, shift. So all the things that are connected to it are available here. So you can actually browse and see what's going on, right? If you play this, right, it doesn't do anything. Play is what we use to see what's happening. If you play it, you don't get anything. Like if you highlight here, there's no data, no data. And that means we have to usually connect them up and put in inputs, just like you arrange a circuit, or you do supply chain or business process flows. Just think of it in that way, right? And the final one here is the help. If you click the help, it discusses, and it's very good. It will talk about the history of it, how do you use it, the different connectors, the different settings. It takes you through all of that, right? But since we want to get started quickly, let's pick a template. So for this, I'm asking people to start with templates. Like this is the Caesar cipher. So if I click it, it gives me already made, right? Oh, this is just settings. I can use to hide or show settings of what I've clicked. So if I click Caesar, those are the settings. If I click text, those are the settings. Now some of the blocks have presentation layers. Caesar doesn't have presentation layer, meaning you can't really view what the input or output is, or you can't enter anything. But a presentation layer just shows you some data, and you can type in there when you have the presentation layer on. If you pick settings, I can't type anymore, but this is a text input, right? So let us play with this Caesar cipher. So let's play it. Let me close this and play, right? So if I typed hello, I use caps for mine, so A to K and so on. And you can see it says HELLO becomes ROVVY. A became K. So you can see it over here, right? Now, if I wanted to see what encryption decryption with 5 is, I stop it and I bring it to 5, right? So 5 is what we had in the Excel sheet. We use 5, but just look at this. If I put 10 in there, this is ROVVY. Actually, that means that what we did in class was just fine. But let me do now 5 and show you that it's the same thing. So let's make this 5 and then play. You can say MJQQT. Right. Now the important thing about shift ciphers is if you copied the output and brought it here, right, or even computed yourself. So for example, if I said I will STDUY, I will study. Our study becomes NBNQQXYIZA. Right. Now, because it's symmetric, that means that if I put the input into the output, so if I put the output, so this is the output NBNQQXYIZ, and I put it into my input. Let me just check what. So this is under encrypt. So if I stop this now and say, please decrypt, and I play, you can see it says I will study. I think I typed I will study. Did I copy everything correctly? I might have copied some things. Yeah, I didn't copy everything properly. I will study. Usually you must make sure you copy character by character properly. But that's what it means. So you can see here that I can easily shift from encryption mode to decryption mode. So if I wanted to decrypt something, usually you'd click the block, modify the settings. There are other things you can look at, but the settings is where most of the action happens, right? And so that means if I wanted to encrypt it, I would say I will study. I would say I want to encrypt it. This is what I get. So I can copy this and then stop it, change it to decrypt, and say whatever that thing is, and say, you see, it says I will study. So that's a really nice feature about this one, right? So this is the Caesar cipher. That's the input, that's the output, and that is the block in the middle.